As we presented in lesson number 1 here in week 3, there are ways to verify the validity of any standard form categorical syllogism or any propositional logic syllogism. Here in lesson number 2 of week 3, we're going to do the deep dive into 2 methods of verifying standard form categorical syllogisms, any of them. The first method is a graphic method. You can see it literally. It was devised by John VENN. It's called the Venn diagram method. And John VENN was a British mathematician and logician at Cambridge University. And he devised this so that his logic students could actually literally see whether or not, using just 3 overlapped circles on the blackboard, whether or not a given syllogism was either valid or invalid. Now we know that out of the 256 permutations and combinations of A, E, I, and O, combined into a 2-premise single conclusion argument, syllogism, only 15 of them are valid. We're only looking at the first 5. So we're going to show you how to make a Venn diagram. There's a video below by a colleague of mine, and this is all from YouTube. It's in the public domain. It's going to show you how to make a Venn diagram. Then we're also going to show you how to test to see whether or not that Venn diagram is either valid or invalid. We're going to be sending you to a link that we have below here, also to poweroflogic.com. It's a very, very reliable site. I used it extensively during my teaching in class at various colleges and universities. And then in the second case, we're going to look at another method of verifying any standard form categorical syllogism. Doesn't matter. We'll be able to tell whether it's valid or invalid analytically up here, just by asking 5 questions, 5 simple questions. So we'll send you to another link at poweroflogic.com. So the purpose here in lesson number 2 is not to explain everything to you, because it would take 2 or 3 weeks to explain just the Venn diagram to students in a classroom situation in a college or a university. But you're lifelong learners. You know how to learn on your own. The book provides you with everything you need in the various sections. Just Control F, Venn diagram, it's all there. Control F, 6 rules, 5 rules, it's all there. Control F, propositional, formal arguments, it's all there. So use your book to fill in what we're not covering here in these notes and in these videos. So first, let's take a look at the video below, which explains what a Venn diagram is and how you can make them. Then we'll discover how you can test them for validity. And then we'll look at 6 rules, which also provide you with a reliable way to test any standard form categorical syllogism, yours or anybody else's. Let's take a look.
This video will show you how to use Venn diagrams to test the validity of syllogisms. First, a little review of syllogisms and Venn diagrams. Syllogisms are arguments with 2 premises and a conclusion. A standard form syllogism includes a predicate term in the first premise, a subject term in the second premise, and a middle term in each of the premises, and a conclusion. The conclusion is a standard form claim, such as all S are P, no S are P, some S are P, or some S are not P. The predicate term in the conclusion must appear in the first premise. The subject term of the conclusion must appear in the second premise, and the middle term appears just once in each premise. Venn diagrams provide a way to visualize logical relationships between a subject and predicate in a categorical claim. 2 circles are drawn that overlap, the left circle representing the subject and the right circle representing the predicate in the categorical claim. In a universal affirmative claim, such as all baseballs are round, the subject is baseballs and the predicate is round. Or to clarify the claim, we might rephrase it as All things that are baseballs are also things that are round. In Venn diagrams, the part of the circle where there are no examples of members of that category is shaded. So in this case, the left side of the circle is shaded. The center area represents all baseballs, and they are part of the category of round things. In the Venn diagram of an E categorical claim, the middle area where the circles overlap is shaded because there are no S's that are also part of the P category. In this example, we want the diagram to represent that there are no penguins that are also traffic cops, so we shade the middle area. To diagram the particular categorical claims, some S are P and some S are not P, place an X in the area of the circle where there is at least one example of that category. In this case, there is at least one S that is also part of the P category. No shading is used in particular claims, only in universal claims. Rabbit is the subject, so the claim says that there is at least one rabbit that is a vicious killer. To diagram the O claims some S are not P, the X is placed inside the S category, but outside the P category. This indicates there is at least one S that is not a P. For instance, this would be the diagram of the O claim, some college students are not millionaires. To use a Venn diagram to represent a syllogism requires 3 circles because there are 3 different terms in a syllogism: the subject, predicate, and middle term. Since the circles form more overlapping areas, it is convenient to number the areas for easy reference. Usually, the numbering begins with the top circle, which represents the middle term. Let's walk through the process of diagramming a syllogism with 2 premises that are A claims. The conclusion is never represented in a Venn diagram of a syllogism, since the conclusion of a valid syllogism is the result of the premises. The conclusion is what the Venn diagrams should say after we diagram the premises of a valid argument. Although the conclusion isn't diagrammed, remember that the subject and predicate terms of a syllogism are determined by the conclusion. Here's the Venn diagram of the first premise, all P are M. Areas 6 and 7 are shaded to indicate nothing is there. The only P's are the ones in areas 3 and 4, the areas that are also part of the M category. So areas 3 and 4 are not shaded. Now let's diagram the second claim, all M are S. For all M are S, areas 1 and 4 are shaded to indicate that part of the diagram doesn't have anything in it. Just areas 2 and 3 remain, indicating that these are the only areas of M that remain. Now that we've diagrammed the 2 premises, we can check the validity of the conclusion. We just need to see if the conclusion is consistent with the resulting diagram. It isn't. The conclusion says that all of the S category belongs to the P category. But there are 2 areas of the S category outside of P, areas 2 and 5, so the syllogism is invalid. Let's test the validity of another syllogism, this time an argument that has particular claims in it. Some P are M, all M are S, some S are P. This is a syllogism with the mood I, and the figure 4. Remember that we indicate a particular claim in a Venn diagram by drawing an X in the appropriate area. The first premise says that there is at least one P that is an M. That means that an X goes in the part of the P circle that overlaps the M circle, areas 3 or 4. But which one? Area 3 or 4? Both are part of P that is also part of M. If we don't know which area to put the X, we draw it on the line between the 2 possible areas. Now for the second premise, all M are S. Remember that we said that the area where there isn't anything, which in this case would be areas 1 and 4, are shaded. So we should shade areas 1 and 4, but there's a problem. We've already added the X on the line between 3 and 4 to indicate it could be in either one, but area 4 is supposed to be empty. So we have to redraw the X and place it just in area 3, then shade areas 1 and 4. Now both premises are displayed. However, there is an easier way to draw them. If you have a particular and a universal claim in the premises, draw the universal claim in the Venn diagram first. Then you won't have to move the X. Is this syllogism valid? Does the Venn diagram say some S are P? Yes, there is an X in area 3, indicating that there is at least one S that is also a P. The syllogism is valid. In summary, use 3 circles in a Venn diagram to represent subject, predicate, and middle term. Number the circles beginning with the top circle. Draw the diagram to represent each of the 2 premises, but not the conclusion. If an argument has universal and particular premises, draw the universal premise first. Use an X to indicate at least one, and place it on the line between 2 areas if it isn't clear which side of the line it should be. After diagramming the premises, see if the conclusion is consistent with the drawing. If it is, the syllogism is valid. If not, the syllogism is invalid. Thanks for watching.
Okay, thanks to that video, we now know how to construct a Venn diagram. So let's see if we can do it ourselves. Follow the link that I've provided below these notes and below the video. And we go to a place called poweroflogic.com, and the title of the page is Pick a Syllogism to Diagram. So let's see if we can do one quickly together just to show you how it's done. So I'm going to share the screen with you now. Now, if you look at the screen, you see on the bottom here, you see 3 standard form categorical propositions. They're all type A. All bland things are crunchy things. That's the major premise. Minor premise is all apples are crunchy things. So crunchy things is the middle term. Bland things are the major term, and apples is the minor term. Leading to the conclusion, so the argument says that all apples are bland things. Let's go and see and use the Venn diagram technique to see if that's actually a valid argument. So we click on continue. So you can see in the toolbox down below, we're going to diagram this syllogism. And here are the tools that we're going to be using right in here. We're going to click shading for an area that we want to shade. If it's a particular proposition, we're going to click particular proposition and place an X in an area. Then we can check the diagram. Then we can clear it and start all over again. So let's take this one. So here we have the circle representing all apples, circle that represents all bland things, and the middle term, the circle that represents all crunchy things. Now you'll notice that the circle representing the middle term, in the previous video, it was on top. I prefer to put it on the bottom. It's just a matter of taste. It makes no difference where the circles are, as long as they're properly representing the 3 categorical terms. All right, so let's start doing. Let's take the major premise. All bland things are crunchy things. Okay, so we're talking about this circle, and we use shading to indicate where we're talking about. So we want to indicate that all bland things, everything that is a bland thing, is also part of the crunchy thing category. So we do that by shading out the areas where there are no such things as bland things that are crunchy things. So we take this one here using the shading tool, and then we use this one here. So now that properly diagrams all bland things are crunchy things. So there are no bland things outside of the circle crunchy things. That's what that says. Now let's take a look at all apples are crunchy things. So that's this circle here and this circle here. So it says all apples are crunchy things. Okay, so we again use shading to indicate There are no apples outside of crunchy things. So we have shaded that area. So we're done. I mean, you don't have to diagram the conclusion. In fact, that would defeat the whole purpose of the Venn diagram. Once you have diagrammed the major premise and the minor premise, you simply look at the Venn diagram and you should be able to see that the conclusion has already been diagrammed in the very act of diagramming the major premise and the minor premise. So let's look at the conclusion. It claims that all apples are bland things. Well, wait a minute. Wait a minute. All apples are bland things? No, if you look at the diagram, this doesn't seem to be right. There's something wrong here, because we can clearly see that there are some apples that are not bland things, right? Right here in this area. But let's check to see if we've done the Venn diagram correctly. So we click on the checkbox. Okay, so we click on the checkbox, and there we are. We have done the correct diagram. All bland things are crunchy things. All apples are crunchy things. The Venn diagram correctly represents the syllogism's premises. Now indicate whether the syllogism is valid or invalid. All right, so if you look at the Venn diagram, it's obviously invalid because the conclusion says all apples, all things apple, are in the same category as all things bland. Well, what about this area here? This is an open area. There may be apples here. There may be apples here. The syllogism doesn't tell us. Here's a place where bland things and apple things are in common. But the conclusion says all apples are bland things. Well, this is obviously invalid. This diagram indicates that this conclusion is not valid. So we click on valid to see if we're correct. Voila. You correctly answered that the syllogism is invalid. So there you have it. This is exactly how you use this particular tool to construct and verify any standard form categorical syllogism, whether it's in a chemistry class or a physics class or a marketing meeting or an advertising meeting or a meeting of a corporation to discuss a Microsoft algorithm to be used in a program, and you're confronted with a presentation that is containing categorical syllogisms and using categorical logic. Well, you can Venn diagram, and then you can immediately see whether or not the syllogism is valid or invalid. That's the first step. Is it valid or is it invalid? We want to know that. Now let's take a look at yet another way in which we can do this. There's another technique, purely mental. You don't need to draw any pictures. You simply use a series of rules and apply the rules to any given syllogism. And if the syllogism breaks any of the rules, you know it's invalid. So here we go. So using the other link that we have below this video, we are returning to the Power of Logic website, and we're going to examine, they use 5 rules. Some logic professors and books use 6, but this one uses 5 because they double up on the negative propositions. And that's how they present 5. Here's a syllogism, says no PRM, no MRS, so no SRP. All right, so right away I can tell you that this violates one of the rules. What are the rules? Well, rule number 1, a valid standard form categorical syllogism must contain exactly 3 terms. Each term must be used with the same meaning throughout the argument. Okay, so that doesn't affect the form. That's just the dictionary. Make sure you're using the right definitions, the same definitions in each of the premises. If you shift a definition, for instance, if you use the word love, people who are in love to mean they love their cats or their dogs in the first premise, and in the second premise, you use people who love their spouses or their best friends. That's a shift in meaning. So we'll cover that when we get into refutation next week. So that's rule 1. 3 terms used exactly the same throughout the entire argument. Rule 2. In a valid standard form categorical syllogism, the middle term must be distributed in at least one premise. Okay. In any rule 3, in any valid standard form categorical syllogism, a term must be distributed in the premises if it is distributed in the conclusion. Rule number 4, in a valid standard form categorical syllogism, the number of negative premises must be equal to the number of negative conclusions. The short version of that is that you cannot derive a universal affirmative conclusion from a universal negative or even a particular negative. So anyway, we're going to use this set of rules. So this particular rule, number 4, seems to be exactly what we're talking about down here. Take a look at this syllogism. This is just the wording of the syllogism. No PRM, that's a universal negative. Second premise is no MRS, that's a universal negative. And the conclusion is, so no SRP. Well, that clearly violates rule number 4. So what we do is we click on this and we say violated rule number 4, right? And we can go all the way through these practice syllogisms to see whether or not they break any of the rules. And we can learn how they break the rules by checking the answers. We're going to check my answer is, look at that. Yes, your answer of rule 4 violated is correct. So this syllogism violated rule 4. This syllogism has 2 negative universal premises. There's the major, there's the minor. Both of them are universal negative. And then it tries to conclude a universal negative as well. It violates rule 4. So anytime you're sitting in a classroom or you're sitting in a meeting, it's a city council meeting or a meeting about a new piece of software that's being rolled out, and you have 2 negative premises trying to infer validly a negative conclusion, it's invalid. Now you can go through this. I'm only going to do one of those with you. You've got the tools to work with. You can make a Venn diagram now. You can you understand how it's made. You can make your own using these links, and you can also test them using these links. And so that is really all we want to do here in lesson number 2 in week number 3. So the only things that are going to be on the exam are the very basic issues that we have covered this week. We're not going to be asking you to do extensive formal proofs. We're not going to be asking you to draw Venn diagrams. We'll be asking you how things work on the exam. So we look forward to that. So in lesson number 3 of week 3, our next lesson, we're going to examine the ways to do formal proofs, how it's done. We're going to show you how formal proofs are done, and then we'll show you a couple of shortcuts to making it a lot easier to do formal proofs in symbolic logic. So stay with us for lesson 3, week 3.